Hey, welcome back to Mr. P Helps with Precal. This is Unit 1, Topic 1, SLT6, and we are going to be looking at piecewise functions and using, talking about discontinuity still, and using limits. And with this warm-up, so it says graph the following piecewise function. So we have here 3 t-charts, so for one for each one, so we can graph it. So I'm going to start with whatever the limitation is, so x is less than or equal to 0, so I'm going to start with 0. So it can also be -1 or -2, and I'm going to plug those numbers in, so 0 squared is still 0, opposite of that is still 0. -1 squared is 1, and the opposite of that would be -1. -2 squared is 4, and the opposite of that is -4. Okay, I do the same thing for the next one. So the square root of x is the function from when x is between 0 and 4. So I will do 0, 1, 2, and okay, so it's square root, sorry. So I'm going to pick ones that are, have square roots. So 0 has a square root, so does 1, and so does 4. So I'm just going to use those 3. And then when x is greater than or equal to 4, so 4 and 5 and 6, the limitation is 5. Well, that's the easiest one because the answer is always 5 no matter what. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. And we're done. So we're ready to graph. So 0, 0. So it is including that 0, 0, -1, -1, and -2, -4. 1, 2, -2, 3, 4. Okay, so that was -x squared, like that. And it's square root of x from 0 to 4, not including either. So 0, 0, actually that's included because it's already there. 1, 1, 1, 2, 3, 4, 1, 2. So it might be closed. Let me see. 4, 5. Yeah, it's going to be closed, or it's going to be open, sorry. So that's that piece right there. So there's square root of x. So it looks like it's just a continuation of this, but it's actually not. Then 4, 5, 4, 1, 2, 3, 4, 5. So there's where it's actually included. And 5, 5, whoops, wrong one. So 5, 5 is actually right there, and then 5, 6, and then it keeps going in that direction. Okay, so is this function continuous at x equals 0? Sure is, actually. So it looks like this function just picks right up, and it just keeps going from the exact same spot. Find the following. F of -2. F of -2 is -4. Or I could have just looked at the table. F of 1 is 1, and once again, that was on the table. And F of 6 is 5, which is right here. Just be careful when you're using the tables because you have to remember if it's included or not included in that piece. So like, for example, zeros are on both of them, so maybe they could have had 2 different answers. Could have been jump discontinuity, and maybe these 2 would have been different. Then you had to make sure that you know which one was included and which one was not. So it depends on the discontinuity, or in this case, it was actually just continuous. So there's your 12 basic functions. We have square root, least integer. We have rational functions, cubed functions, and linear, and exponential, and absolute value, quadratic, and this is logarithmic, and this is sine and cosine. So all the 12 functions that we've been doing up to this point. All right, so we have ourselves a piecewise function. So the domain in this case, it looks like it covers everything to the left of 4. So this piece, and then even this is included in the domain because it has an answer right here, and it keeps having an answer right here. So it looks like everything from -infinity up until 4. Or it's a union of these two, so everything from 4 to positive infinity. So anything over here on the right side of this asymptote, so basically everything except for the asymptote at 4 is a possible domain. And then the range, so another way you could have said that, you could have said the domain is a set of all real numbers. X is a set of all real numbers in which X cannot be 4. Just basically another way of saying the exact same thing. The range, okay, I'm going to be honest with you, I think you need a little bit more information. I can't tell if this is rational or if this is logarithmic. Kind of looks like it's logarithmic, which means it's actually going down into the right infinitely, which means it's going to go up and down infinitely. I'm going to use that as my answer and assume that it's not a rational because it doesn't really look like one. Had this been a rational piece and had this also been a rational piece, then technically this could have been the lowest it ever is, because there would have been a horizontal asymptote. Because since there was no horizontal asymptote given on the diagram, I'm going to assume that it was not. Oh, and discontinuity. So we have 2 different types. We have jump discontinuity at x equals 1. So jump when x equals 1, and we also have our infinite discontinuity when x equals 4. Okay, so graph the following piecewise function from the following limits. Okay, so we have the limits right here, so we're given the information. So we're being told that when x is less than -1, so I'll start with -1, anything less than it would be -2, -3, then this is the function. So -1 squared is 1, 1 plus 1 is 2, -2 squared is 4, plus 1 is 5, -3 squared is 9, plus 1 is 10. I'll do the exact same thing. Keep in mind you can do the same steps with your graphing calculator. So from when x is -1 to 0, 1, and 2. So I use this function. So 4 times -1 is -4, minus 3 more makes -7. Times 0, minus 3 makes -3, 4 minus 3 makes 1, and 8 minus 3 is 5. Okay, so, and then the last piece, the answer is 5. So anytime x is greater than 2, so here's 2, 1, 2, 3, 4, 5. So that's going to be, I'm going to keep it an open circle for right now. Then the answer is 5. So it's going to keep going infinitely in this direction. This one is a linear piece. So -1, -7, 1, 2, 3, 4, 5, 6, 7. And was it including? Yes, it was. 0, -3. 1, 2, 3, 1, 1, and 2, 5. So it looks like it's going to the exact same place. So I'll fill it in now because it was including that one. And then the last one is a quadratic. So -1, -2, -1, -1, 2. Okay, not including. Sorry, I paused for a second. So not including that one. -2, -2, 5, 1, 2, 3, 4, 5, and -3, 10. -1, 2, 3. I'll just assume that that's the top, so it looks like that. Okay, what can we say about the limit of f of x as x is approaching 2? So as x is approaching 2, it really doesn't matter if it's approaching from the right-hand side or the left-hand side. The answer is always going to be 5. It doesn't matter which side it's approaching. It could be both positive or negative. As f of x is, as x is approaching infinity, you know, it's going to be 5, because no matter what it is to the right-hand side, it's going to be 5. As x is going to the left, it's going up towards positive infinity. The further you go to the left, the further it goes up. As x is approaching 1 from the left-hand side, I'm sorry, -1 from the left-hand side, it's getting closer and closer to a height of -2. As f of x is approaching -1 from the right-hand side, it's getting closer and closer to this value, which I believe was -5. No, it's -7. As the limit of f of x is getting closer to 2 from the left-hand side, the closer it is getting to 5, and from the right side, it is also getting closer and closer to 5, as we had mentioned before. And very similar question to what we just did. I'm going to skip this one, give you that one as practice, and I want to make sure I have enough time to do one of these solving ones. So the key here is the fact that they're telling you it's continuous. Since they're telling you it's continuous, then you know that this piece is going to end in the same place that this, at the same height, if you want to be specific, as this piece begins. So the key here is to find out where does this piece have a height of, because this piece would have to have the same exact height. So 3 is x for both of them, so I'm going to put 3 in for x. So 3 squared minus 2, 3 squared is 9, minus 2 makes 7, which means we know that this one also has a height of 7. So 5 times 3, because we know x is 3, minus something equals 7, because we know it has the exact same height. So this is 15. Subtract 15 from both sides, you get -a equals -8. Divide both sides by -1, and you get a equals 8. So now I know a equals 8. There's my answer. So I solved for a. I would do the exact same thing here. So just keep in mind that this piece and this piece, since they're continuous, are going to have the same answer. They're going to have the same height. So you put 2 in for x and solve. Once you put 2 in for x and solve this one, just set this one equal to the exact same thing, because x is 2 again. All right, thanks again for watching, and please give it a like to help you learn something about piecewise functions and how to use limits to determine. Thanks again for watching. Have a great day.